All right. Good morning, everybody, and thank you for joining us on today's very special edition of MetalCon Live and the NCA Present. MetalCon Takes on Solar, a metal roofer's guide, a metal roofer's perspective on solar installations. Today's session will be presented by Dustin Haddock of S5, Bob Zabzik of Z-Tech Consulting and the MCA, Leanne Slattery of ATAS, and Mark Geis of S5. We also have as a special guest who's helping answer some questions on the back end. We have Andy Williams from the MCA as well. Next week, we are going to, 2 weeks, we will be presenting another MetalCon Live presentation, 7 ways to blast past supply chain, talent shortages, price pressure, and other metal construction profit killers. This will be presented by Frank Stasiowski, Alex Carrick, and Tony Bucquo. This is a return to one of our favorite presentations that we do on a quarterly basis with Frank Stasiowski as well. So be sure that you mark your calendars for that. The MCA is today's sponsor for today's MetalCon Live. If you have any questions about membership, including how to get a 10% discount exhibiting at MetalCon, you can reach out to Jeff Irwin. His contact information is on the slide here. Don't forget, MetalCon is coming up in just a few short months, everybody. You can get on the pre-register list right now. Also, really exciting news. Our registration will be going live in the very near future. So be sure you check out our website and check back pretty regularly for additional information. Don't forget, at the end of today's seminar, if you need to get your AIA credit or want to receive a certificate, please fill out the survey that comes at the end of this. That survey is not shared with anyone, and it's just a way for us to gather your AIA number and the email address you'd like us to send your certificate to. If you run into any technical issues, please feel free to message me, MetalCon Live, in the chat box or in the Q&A section. I can help you out there. For all questions today, please submit them as you have them. All questions will be answered closer to the end, but we want to see what questions you've got as they come through, the way we can help better answer and have a much more concise response towards the end of that seminar. You can submit those questions either in the chat or in the Q&A section. Without further ado, I'm going to hand this over to Leanne, Mark, Bob, Dustin, and Andy. Thanks, everybody. Here we go.
Thank you, Kaylin. As most of you are aware, the solar photovoltaics, or otherwise known as solar PV industry, has been rapidly growing, not only in the United States, but also globally. And it's going to continue to go that way. Not only the environmental benefits that are achieved by using solar, it's also a sound investment to provide carbon-free electricity and lower costs than traditional fossil fuels. So although today we're not going to dive into so much the aspects of the PV itself, the PV as a rooftop solar system works alongside the roof that it's going to be installed over. So that's one way to achieve some of your longevity and cost savings, is to look at it as an entire system or an asset. So I like to think of especially standing seam metal roofing as the perfect platform, or a solar ready platform for these solar PV panels. So we're going to jump right into this here and start off with the obvious first question would be, why is metal the perfect platform for solar, for a rooftop application? So let's start off with Dustin here to talk a little bit about the service life and availability or durability. Before we do that, though, a quick mention: much of what we're going to be talking about today has been covered in 3 white papers that are now available through the Metal Construction Association. All of these have to do with metal roofing and solar PV systems, and it's broken down into a 3-part series. So we start out with the service life comparisons, and then move on to mounting system methods, and then finally the mounting system installation. So again, I'll remind you at the end of our presentation, but these are great resources to look into if you're considering getting into this end of the business with solar PV. So moving on now with Dustin. Would you like to start off the discussion and just talk a little bit about the service life?
Yeah, thanks, Leanne. This is kind of the first and most obvious that, has has kind of gripped the solar industry when looking at your mean service life of a metal roof as compared to other roofs. Here you're looking at a chart that's showing the different stages of life of various roof types, with metal coming in at just plus 60 years, coated steel, where some of your more common roofs, TPO, asphalt shingles, in many cases, way less than half the actual mean service life of metal. Why this is important is because when you're looking at putting or retrofitting solar onto a roof, that's a 25-year plus warranted solar panel. There's even modules right now looking at going beyond that 25 years. Putting that 25-year power supply on a 10 or 15-year roof, what that ultimately means is the roof will expire before the life of the solar assembly. So ultimately, you're going to be installing solar, then your roof dies, expires in terms of its service life. You pull the solar off, re-roof, and then put the solar back on. With coated steel, that's not an issue. And so you're not installing the system 2 and 3 times. You're installing it one time, which in terms of life cycle costs is extreme savings. We'll kind of dive into that a little bit later.
Great, thanks, Dustin. You know, as I mentioned earlier, the sustainability aspects of metal roofing are a big reason why people would choose to go that route. So Bob, can you talk to us a little bit about sustainability?
Sure. It's actually, it's really good that Dustin made the point that he did about service life going into this discussion. And we'll talk about that in a second. Here's some stats regarding just general use of landfill space used for obsolete roofing materials that came from, well, you can see the NAHB, National Association of Home Builders, and the Public Works Corps of Engineers did some studies. Just back up one here real quick. Just to kind of give some basic information on how much landfill space is used for roofing materials. It's pretty amazing. So that service life essentially means, you know, you skip that for that impact for roofing, metal roofing. And it's important to remember that, because when you start looking at sustainability, it's not just your impacts, your environmental impacts that you have to address. They're actually spread out over what's called a use phase. So the longer that material functions and performs its basic function, the better and more impact you get. So what we're seeing is a movement in the market and sustainability and really moving towards from a single attribute type of approach, which is what recycled content would be. You know, I'm putting all my sustainability eggs in the basket of recycled content, so to speak. And we're moving from that to a really more global, holistic approach through LCA and EPD. So go ahead and hit up on the next slide, Mark, and we'll talk a little bit about what that means. You know, we have done, like a lot of other industries, we as a metal roofing industry have done a lot of work with LCA here lately in the last 10 years, producing EPDs. And, you know, a lot of folks are using those, downloading them. It's one of our more popular downloads, but a lot of folks are using those for their projects, their lead projects or whatever program they're operating under. And what you got to remember about these things is that, you know, when you download an EPD and you get that data, it's broken down into different impact categories. There'll be global warming potential, ozone depletion potential, acidification potential, eutrophication potential, smog formation potential, and then what they call abiotic depletion, which is depletion of non-renewable resources that focuses mostly on fossil fuels in the construction. But these are really very data-driven approaches, and they're, you know, dictated by ISO standards. And there is a differing functional units. When you download the EPDs, you'll look at, like, for instance, our EPDs that we have on our website, and it's also hosted on UL's website, focuses in on 100 square meters of cladding material. That's about 1,080 square feet if my metric conversion in my head is working correctly. And you have to resolve those functional units between different materials. And then those EPDs, even though there are documents called PCRs or product category rules that kind of drive the scope of the EPDs, those PCRs are not necessarily, they're very well coordinated within materials, but not necessarily well coordinated across materials. So you have to go and look at the scopes and address the differences in scopes. And of course, you have to, I mentioned all the impact categories. A lot of people tend to focus on global warming potential, for instance, which is your carbon release. But putting all your attention on that, takes away from other things, and you might be paying a greater penalty. So how do you weight those? These are really things that are outside the scope. That last subject is really kind of outside the scope of typical LCA, and they're really looking towards the individual programs or authorities having jurisdiction or whoever to make the decision about which of those are more important than others. So it's a right way to go. It's holistic, it's data driven, but it's complex, and there are a lot of layers to it. So go ahead and hit the next slide. But like I mentioned, we have done a lot of this work like many of the other industries, and we have those industry average environmental product declarations available on the MCA and UL websites for 3 core materials that our membership makes. Roll forms cladding, and that's both steel and aluminum roof and wall panels. Insulated metal panels, if you're familiar with that, those are basically composite panels, 2 metal skins with a foam insulation core. And it's a multifunction assembly, so it also kind of has some unique things about it in the use phase you really need to consider. And of course, metal composite materials, which are aluminum panels that have a core material on the backside that's mostly for flatness. It's not necessarily an insulator, but those are used over cavity walls, and a lot of our members are make those materials. So those 3 EPDs are available for download. And if you have any question, of course, there's an Ask an Expert link on the MCA website. So feel free to click it. It'll come to me or Andy, and we'll answer your question.
Thanks, Bob. I think a lot of building owners are really interested in exploring rooftop solar systems for their buildings. But like most things, a lot of it comes down to budget and cost. So Mark, can you talk to us a little bit about the life cycle cost of such a system?
Sure, thanks, Leanne. So, I guess the first wave of solar in the 70s was really all about the environment, with sort of the culture of the hippie, the California hippie being disconnected from the grid. It has really become the last couple decades now. Again, it's of course it's on the rise again, and now a lot of it is about the cost and how much you get out of it, that value, and it's become really a worthwhile investment. And we've been talking about the longevity of the service life of a roof and the value of that. So when you couple a solar asset with a roof asset and look at it as one asset, you can really see the advantages of a metal roof. And so if we look at the cost stack up, yes, a metal roof is more expensive than other types of roofs like shingle roofs or single ply membrane roofs. But once you put the solar in, solar is a little bit less expensive on metal roofs, especially standing seam metal roofs. There's just less material, less labor involved. So when when you have now your total system, you're really ahead of the game with metal, lower cost with metal roofs. And, arguably, things are, everything's different. Every project is different. So you're at least even, but the benefit now, you have now a metal roof on your building. So, and really where the cost comes in. So here's really the cost comparison of an all single asset. Now we talked about this. What happens if these other roofs that don't have that life cycle, don't have the service life as long as the metal roof? So you may end up having to pull out and replace the roof in midst of the life of the solar system. So that cost, if you put that cost into it, it becomes a no-brainer. It really shows that total cost is, and this is in sort of roofers terms, metal in construction terms, square foot. People in the solar industry think of things as dollar per watt of what they install, but this shows that you're way ahead of the game if you look at the life cycle cost and look at this as a single system, a single asset. And another way that people look at this is with what I would call—
Mark, before you move on, can you dive in a little bit in terms of better describing why the total first cost as it relates to solar on metal, just a little more detail as to why that's cheaper than when looking at other roof types?
Yeah, Dustin, and you can chime in your perspective as well, but it's we'll get into that as far as different types, but generally on a metal roof, you'll see a flush system. So there's very little material. There's less material generally, especially if you do not use rails, because metal roofs really have rails. And then specifically standing seam roofs, you're not penetrating the roof. So it's very easy to grab a hold of the roof at the seam and then install the solar modules onto it. So that labor and less material with less rails, if you're not using rails, that all adds up to a lower installation cost, all in. Do you have anything else you want to?
Yeah, I mean,
I was just going to say, if for the audience members, that they, hearing the terms the rail and the various, we actually have some slides later to show what that is.
Right.
So hang on with us.
Right, and then, I mean, the other part of it in terms of, installing jacks that need flashed and waterproofed and whatnot, takes a tremendous amount of time and energy and labor, and so
Yeah, so for other types of roof, you're flashing, you're penetrating that roof. Standing seam roof, you're not there's no penetrations. So to sort of put a point on the replacement cost, it's very common. I don't know if anybody's familiar with this. It's very common to look at the value of a solar system in terms of cash flow analysis. So this is really a cash flow analysis, that the line on the left side, that's your initial cost. Your black horizontal line is your yearly savings, and that just adds up with the orange line. And this system, this is just an example, has about a 6-year payback. So the rest of it is that's your net positive cash you get over a 30-year period, the life of the system. And it's common to measure these things with cash flow at what's called net present value, or IRR, which is your internal rate of return. And this is about what you get. So you're investing $145,000 and your net present value of all that cash is $276,000. This is an example. And the IRR, your return is about 21%, which is a great return on your money for putting that in. But now, if we talk about the potential with other roof types of having to, in the middle of the life, put a new roof on, this is how to visualize that. Like in the middle, like say at year 20, you have that dotted line, which is your cost of replacement and with time without power and putting everything back on together. So what that does is that, really wreaks havoc on your total cash flow as visualized there. So that, that blank area is really your lost cash opportunity that you have from having to do that in the middle of the life of your solar system. So that's the value of putting it on an asset on a roof that lasts longer than the solar itself. So that's really all I have is on that ROI, but you can really see how valuable it is to put solar on metal roof.
Thanks, Mark. And now we're going to move on and review some basics about metal roof and the solar panels. Bob, can you touch upon the different types of metal roofs over which a PV system could be installed?
Absolutely, Leanne. Before I do, though, I'm going to make a follow-up comment to Mark's. Do you need to back up slides, Mark? Just follow-up comment to Mark on the cash flow analysis. This is not magic. This is the same kind of analysis you do on any project. Construction, financial investments, it's all the same rules. And what's has always interested me about the sustainability aspect of this too, is that's not really very different from what you're doing with sustainability. Your initial investment or your initial impacts that you get from an EPD, but it's use phase that drives what your actual performance is, and why it's very important to don't stop at EPDs. That's the short answer. Look into drive this all the way across to cradle to gauge situation with a project specific LCA. It's very much that same concept. But yeah, going back to the roofs options, Mark has mentioned both of these systems already, or Dustin as well. So, they fall into kind of two general groups. There's on the bottom left there, what's the exposed fastened metal roof or through fastened roof or panel roof. You'll hear it called a lot of times. And this particular visual example is installed over open framing or Z purlins. And then on, well, in the middle part, there is just a section on what one of those side lap details looks like. There's a lap fastener and tape seal in there, and that's significant for diaphragm action and of course leak resistance. And we're going to come back to an important point about that in a second. But up in the upper right hand corner is a visual example of a standing seam metal. This particular example is over deck. Over a drawn wood deck. Now, I think the important thing to remember is that this is actually, there's cross-pollination too. I can have a through fasten roof over a wood deck, and I can have a standing seam roof over open framing as well. And all of the requirements, the performance requirements for these are of course driven by the International Building Code, Chapter 15. So if you were to look and open up your IBC, look at, for instance, section 1504.3, where it talks about performance requirements for wind uplift for these various systems. So the deck systems, be they standing seam or through fasten roof, their performance requirements for wind uplift are generally driven by UL 580 or 1897. And then for standing seam roofs over open framing, you can do the test that's cited is ASTME 1592 is a vacuum chamber test. You can do vacuum chamber tests for through fasten roofs as well, but you don't necessarily need to. The underlying AISI code allows you to do calculation for this scenario over open framing, but it still need to be tested to 580 or 1897 over deck. So all this is important because, one of the main things the roof does is it resists uplift, but doesn't just resist wind uplift. It's providing you leak resistance during that period of time. And one of the aspects about wind loads came all too apparent during the Hurricane Andrew in Florida, when we saw a lot of debris being picked up off of roofs, rocks from ballasted roof, or just pieces of glass or 2x4s or whatever that were driven into other buildings. And so you had a building that was probably doing okay, or certainly could have been doing just fine in terms of storm resistance, and then it gets hit with this flying object, and that's called windborne debris. And so there's a lot of aspects about this design that's important to keep your solar panels on that roof, because in those types of events, you don't want that solar panel to become a piece of windborne debris. And so you'll hear a lot about penetration-free systems. Mark mentioned that. So the standing seam panel there has a seam. As it says, profiles vary, but you can get all kinds of different hardware and accessories to attach directly to that seam and essentially turn that seam into a rail. And by doing that, you've not just eliminated the material, but you've also created a situation where the panels, the solar modules, PV modules, are closer to the plane of the roof. That's important from a wind resistance standpoint. We'll talk about that here in a few minutes as well. But the key thing is that this whole system still has to function to resist wind. Particularly for rack-mounted system, those wind loads can be quite a bit higher, or at least more concentrated is probably a better way to say it. And so you've got to, that comes into play with the design of the anchorage as well. So why is, it's really one of those things that you wind up not spending a whole lot of your overall budget of a solar project on the mounting system, yet you could argue it's one of the more important parts of it, because it ensures that PV system's durable, will last a long time, but most importantly, won't come flying off the roof and cause other problems. So you get the penetration-free aspect of standing seam roofs, but it's also important to remember, while there are a lot of options to attach metal roofs onto exposed fastener roofs, and they all work well, and when installed correctly and monitored importantly. But the key thing is that if you've already got fasteners penetrating your roof, like you do with an R panel roof or through fasten roof, then maybe your impetus to get a penetration-free system on the PV may not be so important, as long as those penetrations are correctly treated, and that's how they're done in the side lap. And so there's great advancements in the fastener industry for sealing washers and long life fasteners with heads on them, domed heads that do a great job at resisting leaks. And every metal roofing every metal roofing installer uses them, knows how to use them, should be able to install them successfully with a screw gun, which is why it's really important you want a metal roofer doing those installations, because the solar guys may not necessarily know those inherent details.
Those are some great points, Bob. Now that we've talked about the types of metal roofs, let's move on with Dustin. Can you touch upon the structure that are underneath the roof panels and the connection of the roof to the actual structure?
Yeah, I think Bob hit almost all those points pretty well. The one thing that I would like to kind of point out is what he talked about in the roof itself, kind of becoming a rail. In the sense of you've got a rail every 12 to, in many cases, 24 inches, depending on the roof. It gets wider with other roof profiles, but you've got a rail there every 12 to 24 inches. And when it comes to load and spreading the load uniformly into the roof, into the structure, that gives you a point of attachment directly to a module, which is going to spread the load from the modules into the roof in a more uniform manner than what you would see with a typical rail installation, where the rail is fixed, every 3 feet or something like that, 3 to 4 feet, where they're point loading the roof itself in those areas. But that's kind of, Bob covered this pretty thoroughly. I would like to dive into the next slides for sure on just solar on metal roofs, so we can kind of see this coming into play.
Yeah, I think a couple of folks have asked about it. So here's
right.
your eye candy. Here we go.
And I think, Mark, you're going to talk about this. What you're looking there to the left is a building that's Apple World headquarters. Every module there is fixed. That's what we call the direct attachment method. But this is an interesting one because you see the space gaps between, and the modules mounted in portrait. Typically you'd see them in landscape on a standing seam. But there you're seeing a flush mounted system. Both of those are flush mounted systems. But I'll let you go from here, Mark.
All right. So this is just an overview of the two basic extremes. One, this is, as Dustin said, Apple headquarters, it's a 7.4 megawatt, huge system. And then on the right is just a typical residential installation, probably maybe 5 to 10 kilowatts, pretty small system. So let me just go through the basic ways that you see these attached. So on metal roofs. So it's common to have, probably the more common type is having a flush mount system, meaning they're no tilt, they're flat, and they're very close to each other because there's no shade involved. So they can actually be touching each other, like in this picture. And you can see in this circled area, those are the rails. So the rails are clipped on to the seams, and those are typically would be a standing seam clamp, which is a clamp with just a set screw that interlocks, that mechanically fits into the seam that prevents it from uplift. No penetration. That's like the key to these roofs, is you don't have to penetrate. Here's another picture. This is
Mark, if you could go back, I want to try to grab a question that just popped up that this slide kind of answers. On a typical rail system, what you're seeing here is the module being fixed to the rail then being fixed to the standing seam. You see that circled there in red. If you look further down to the right, you'll see where that module then is again fixed to the rail. But that connection of the rail to the roof may or may not exist on that next seam. And so when you're talking about spreading the load more uniformly into the roof by doing a direct amount attachment system, you're taking the module directly to the roof as opposed to the module to the rail, then to the rail to the roof, which that rail is more than likely not going to be fixed as frequently as if you were to take the module itself directly to the roof. And so that spreads the load more uniformly into the roof than most typical rail applications.
Yeah, if you look at that rail, one of those rails, they're probably, at 6 feet before you hit the next attachment. So there was more connections from the modules to the rails than there is from the rails to the seams, as Dustin said. So if you got rid of the rails and mounted directly to the seams, you'd have a higher distribution, lower point loads. So here's another view. This is a steep slope. It could be residential, flush again, rail based. Those red lines are where the rails are. Typically, this would be portrait. It's the same concept. You're attaching the rails to the roof, and then you're attaching the modules to the rails. As opposed, another type of flush mount is a direct attach. So the concept is, the argument is that the rails are there. See the circled area, those seem just like the rails that showed in a rail-based system. So the rails are there, so why put a rail on top of a rail? That's the argument. And then, as Dustin said, there is generally a higher distribution, more distribution of loads because there's more touching points to the roof. And without the rails that have to be pre-measured and laid in exactly ahead of time, most of this stuff goes on the fly, and the module itself is the jig as you build. So the concept is it's just less work because, less logistics, because there's no rails involved. And we could talk more about that. And so then the third basic type is a tilted system, and there are tilted systems on metal roofs, as you can see. The attachment to the roof is basically the similar attachment. Then there's a mounting system on top of that, and that's tilted. Now with a tilted system, you have to have a space in between these rows, as you can see, because of shading. So the trend has been definitely going towards a flush system. Those are much more common these days. And it's because solar panel costs have gone down. So it's better to have more panels. People tend to want to have more panels on the roof, even though they're giving out less energy in a given year. Just that's generally what people want now. So they'd rather go with a flush system or very low slope. So there's not that much of a gap, and you can just put more solar panels on your roof.
Yeah, kind of to discuss that a little more is with the, in the 70s and 80s and even early 90s, the cost of solar panels was a lot different than it is today.
Yeah.
And, making a module as efficient as possible was kind of priority because of how expensive the modules were. When you're looking at a tilt mounted system, it's a good idea to compare. So look at that system as a tilt mount system and the production that you would get. Also look at the space loss and the expenditures of the added hardware to tilt it up.
Yeah.
And then compare that to a flush mounted system by adding more modules, using the space on the roof as much as possible before making decisions on tilted systems.
Yeah, the cost of a tilted system is generally more than a flush mount because there's just more material, more work involved. So that goes into play too. But basically, people are willing to give up a little bit of energy on an individual module to get more total energy by putting more together in a flush mount system. So
All right.
that ties in with what is required to put a system on a roof.
Okay, and we're going to move on. At this point, we're talking more about the technical factors of mounting the PV systems on metal roofs. And we have to keep in mind the PV system mounting, that's only about 5% of the total system cost, but it's such a critical factor when it comes to performance. So Bob, can you talk to us a little bit about that?
Sure. I'm laughing because one of the messages just came across the screen about tilt systems and the wind loads involved by a gentleman by the name of Keith, and I'm looking for the camera in my room because he apparently has figured out what my next slides are. So congratulations, Keith. Let me know when you head to Vegas. All right. So what we're going to look at a couple of things. But before I kind of get into that technical aspect of it, let's just back up for a second and talk about roofs in general and what they do. My background is in structural engineering, so I have installed my fair share of metal roofs. My family was in the business, but it has been this is a passion area of mine because I firmly believe, like most engineers, if you're going to do something, you can do it right. And I think with solar in particular, it's a big investment. And as Mark has shown you, it's not just something you do to feel good about you can feel good about the environment, but it actually is something that is financially a viable investment. It outperforms a lot of other investments. And so it's a deep passion area of mine. So what is the risks that you undertake by putting a PV system on a roof are not inherently different from the risks that are with that you come along with any roof. without a PV system, but the PV system accentuates certain things, and you need to keep that in mind. So let's just talk for a second. What does the roof do, right? Well, number one, it keeps water out of the building. I think that's the main thing that we're trying to accomplish. It does protect the building from wind, and is exposed a lot to wind damage because there are really a lot of unique things that happen when a wind stream hits a building. Particularly, I'm going to say something kind of silly, but there's a reason why, particularly buildings close to the ground, because a lot of the wind research that you see, all buildings are close to the ground, right? But a lot of the wind research that you see is based off of aerodynamic wind tunnels on PV systems that have been tested using the type of wind tunnels that are used for aircraft design and that kind of thing. So Factory Mutual, if you know who they are, they've done some research on this and published some guidance on it. And they should really, you really need to focus on results that have been generated by what's called a boundary, ground boundary air tunnel. And so ASCE got into this. Actually, they got into this after the SEAC, the Structural Engineers Association in California, started doing some research on this and really looking at the air tunnel, the wind tunnel tests, used the ground boundary layer type of air tunnels, and they came up with what I'm getting ready to show you. But first, there are some other aspects that are away from wind that I will mention here. First off, snow and ice accumulation can be an issue at times, and so that's all part of inspection. But there are provisions already in AAC 7 for what's called aerodynamic shade or snow drifting in areas to equipment. So PV actually fits right into that. So it even though it doesn't specifically recognize that now in ASCE 7, number one, future versions will. It's in 2022 to specifically address PV panels, but the snow drifting due to the panels themselves are really already covered by the rooftop equipment. Another thing that you might miss, a lot of people think, okay, I'm putting weight on the roof and you need to make sure the roof can withstand that weight. And that's important, obviously, but you're kind of doing a trade-off because generally speaking, solar panels are not walkable. So you're kind of taking away roof live load and replacing it with some dead load. So that you might feel good about that, but there's one aspect of this you need to remember. I'm also increasing what's called the seismic mass of the building. So I put this equipment on this roof, and if you're out west or someplace where there's seismic activity and earthquake hits, that building's still going to vibrate at that same frequency or close to it. But now it's carrying a lot more mass. More mass means more force. Newton's famous equation, F equals ma. So you pick up extra seismic force, lateral force, when you add a PV system. So it's important to really be cognizant of those risks. ASCE 7 2016 has done a great job with wind loads. So this is just your basic wind speed map for risk category 2 building, which is your basic building. It's not low use, low occupancy, and it's not assembly. It's just your typical building. Pretty standard. You pick off your location and then you get your map. Or you get your wind speed. So what do I do with that wind speed? Next slide, please, Mark. Well, this is where you get into your roof design, and there's a series of calculations that you do that produce some of the sample results that you see. And you'll see within chapter this. I'm not talking about PV systems yet. This is just the roof. We'll bring the PV systems in here in a second, but this is a hot zone map, if you will. They call the wind zone map, but I like to call it the hot zone. So this is where particular areas of the roof experience a lot more load than others. And those examples that you see, I'd probably tell a story better than I can explain it, but you can see more than double on the extreme edge corners versus what's in the main part of the roof in the middle. So what you see on the left is a plan view of a hip type of roof, and then on the right, it's a gable type of roof. Both of these are in the slope of 7 degrees or greater. Or excuse me, 7 degrees or less. Well, there's two tables. These photos come from this less than 7 degrees. There's another table for higher, steeper slopes. But then you run through these calculations and those give you your numbers. Okay. All right. That makes sense. What about the effects of the PV system? So that's the next slide. And this, I think, was what Keith was driving at. And so this is, first off, ASCE 7 breaks these systems into 2 groups, very much along the lines of what we've been talking about. There's There are rack mounted, there's provisions for rack mounted PV systems on low slope roofs. That's what you're looking at right now. That is, check my notes here. I think that is 29.4.3. And then there's also provisions for the flush mounted over steep slope roofs. Those are 29.4.4. This picture is from the low slope provisions, but the flush mounted kind of ties into this as well when you read it, that there's no unique drawings. But this is going to illustrate some points that I'm trying to make. There are inherent things about these corner zones within this map. So the PV module itself can experience greater than average, just to put some terms to it, greater than average wind load to, number one, its location on the roof. And we saw that with the wind zone maps. And so this is kind of repeated here. That's what that top left diagram is showing you. But then they also can experience greater wind loads when they are the edge of the array. And that's what's on the far right, solar panel plan. Those shaded areas actually get a little boost in load. And then in between the two, up at the top, there's a building elevation that shows you, how the tilt and the distance, the offset, if you will, the distance from the roof affect the wind loads and how they're applied. And all this ties into the two charts you see on the left-hand side, bottom left-hand side. They talk about normalized wind area. So what's interesting about solar panels, if you're familiar with ASC 7 wind design, they break everything down into main force, wind resisting system, and components and cladding. So the framing systems for PV modules are considered main force, wind force resisting systems. But if you plow through the provisions, you notice there's a lot of commonality with what's for the components and cladding. One of those things that are very common is that the area, if you will, the area of that's receiving wind load for a particular element, as it gets smaller, the chances of that element seeing higher loads get greater. So one of the calculations you do, you use this pressure coefficient you get off the left-hand axis, and you can see as its area goes down, those zone maps, they get very high. So it goes from like 2.4 down to what's that, about 0.5. So that's almost more than 4 time increase. So those are big aspects. So what is that normalized wind area? Well, effectively, it's like the effective wind area, but really what it comes down to is whatever you're designing, let's just talk about a particular connection point. It's the amount of area supported by that element in terms of wind load. That could be a single module, could be a row of modules, could be a cluster of 4, just depends on your framing system. The key thing that I'm trying to get a point across is that that area has a great impact on the amount of load, and you have to very carefully select that area. And a lot of times you'll see guidance that doesn't really talk about this. And so really as an engineer, you got to look at each component and its respective supported area and wind load and make this determination on what this normalized wind area is, pull these coefficients off, and then do your math. And what you'll find out is that these loads can get quite high, particularly for clusters of PV modules that are both at the edge of an array and also near the corner of the building. So you got to pay a lot of close attention to that.
Thanks, Bob. Now that we've covered the roof conditions, let's move on with the topic of equipment performance and testing, the product testing of the individual product. So Dustin, is that something you can comment on? Dustin? There you go. Oh, you're muted.
It's muted. Sorry about that. I'm going to try to be as brief as I can, so we leave plenty of time for questions here at the end. But what's really important is making sure that the product that is being selected for the application has been adequately tested for the kind of loads that it's going to see or weather conditions it's going to see, metallurgically compatible with the roof itself. Here you're looking at some submergence tests. You know, the industry tends to like to look at wind-driven rain. Some manufacturers will take it to the next level and run that ASTM E2140 test, which is 6 inches of static water pressure over any component that might penetrate into the roof. To the right, you're looking at pull tests where clamps are pulled specifically on the roof that they're intended to be used on. You can jump to the next slide. And then metallurgical compatibility. These are just a couple of things that one should be looking at when selecting a system to marry the modules, this PV system, to the roof. This is a 2,000-hour salt fog test illustrating a product that will essentially outlast the coating on the roof. Here you see the coating is completely annihilated, but the fastening system is still there and in good shape metallurgically. I saw a question come in from Mustafa asking about 2703 and grounding and bonding, which is UL 2703 is a UL standard that tests everything from the rack up, and grounding and bonding is one of those things within that test standard, which is module specific. 2703 has fire rating performance. It's got mounting mechanical load, grounding and bonding, all within that standard. And when I say grounding and bonding, that's maintaining that anything that's likely to be energized has a ground path, a path to ground, to prevent somebody getting shocked accidentally by touching a piece of metal or something like that that they didn't realize was energized. It's important when you're looking at your racking system to make sure that it has been tested to these standards as well. Absolutely. So I'm kind of speeding, so we leave time for more questions. So feel free to ask more about that here towards the end, but let's get to these next. The checklist kind of brings us all together.
Now, let me interject one thing on this, though. I mean, I see this test as not necessarily about how just rusting and longevity, but it's really about material compatibility. Are the right materials being put on a metal roof that will not create? Because if there was some incompatibility from a metallurgical perspective, the result of this test would be that the materials would be just destroyed. One of the materials, which depending on what part of the scale it's on, right, Dustin, would be just dissolved pretty much. So this just shows that an important part, I don't know if you can stress that with metal roofs, you want to make sure you put the right material on them. And whether you have a steel roof or a copper roof, it really is important, the material, what touches the roof.
Yeah, and I mean, a question that kind of just came in was, in terms of dissimilar metals.
The galvanic reaction.
That's why we're running, that's why it's important that these kind of tests are run. You wouldn't want to use an aluminum clamp on a copper roof. MCA has published a document or a couple documents that make fastener recommendations for various types of metal roofs. That is an industry-wide kind of document that is a good go-to in if there is any questions about metallurgical compatibility or dissimilar metals. The test you're looking at right now is a galvalume roof with an aluminum clamp and stainless steel fasteners. That MCA document I'm referring to takes kind of a deep dive in looking at stainless and aluminum and why you can use stainless and aluminum. So if you have a situation that's saying, I have an aluminum roof, is it okay to use a stainless steel fastener? The answer is going to be yes, due to the surface area. But if you were to flip that around and say, okay, I have a stainless steel roof, is it okay to use an aluminum fastener? The answer would be different because the surface area of the more noble metal is greater. And so I really would recommend having a look at that document because it illustrates a lot of these commonly asked questions within the industry and what is acceptable from an industry standpoint when utilizing various metals in combination.
Good point. So I mean, Leanne, I'll just dive right into the checklist part of it. So we already talked about the importance of site condition, knowing your site conditions, as Bob talked about.
Advance. Yeah, if we could advance the slide.
Yeah, I'll do that. Yeah. So so the importance of the understanding that site, getting professional engineers to look at the site, make sure that you calculate the right forces that are going to be on it that you need to resist. We know the importance of having the right product, have that engineered, have that tested. It's also important the company that you're buying it from. I mean, is that company, what's its track record? I mean, what testimonials, what are people's sort of conclusion of doing business with that company you're buying a mounting system from to put on a metal roof? That's as important. And beyond sort of how, is a company a good company to deal with, customer support, also, how do they manufacture, whether they contract it out or manufacture in-house? Do they, do they have an ISO 9000 listed manufacturing plant? Do they produce with quality standards that guarantee that each product ship is going to be to that spec of that product with the right material? Do they certify that and by an independent auditor? So if you put all those together, and this is the thing that we did at the end of this third paper for MCA, was we put all those thoughts together on, like, this is a good checklist to use, whether informally or formally, to like go through and say, this is the things that are important, and have I done this, and who's the responsible party? So it really gets into about the project, site conditions, the building itself, then the materials used, are using the right type of aluminum, or using the right, are the aluminum parts per the correct specs? I'm not going to get into the details. It also gets into the sealants and the really important conditions that we really haven't reviewed, but gets into that aspect. Then it gets into the manufacturing, just what I was talking about. So it's a really comprehensive list to say, this is all that's important when I create this system and put it on my roof, my metal roof. And the point of this at the end of this third paper was just sort of the collection of all the thoughts we talked about. So that's kind of how I'll we'll end this part of it now, I guess, unless Leanne, you have.
No, in wrapping things up, I just want to reiterate what Mark said. This particular checklist can be found on page 3 of the part 3 white paper, mounting system and installation. And as Dustin had mentioned earlier about another white paper that the MCA has published, if you have not been on the MCA website recently or checked out all their educational resources, I would encourage you to do so. There are a lot of different resources on there, whether they're white papers or webinars that you can view, videos. There's a whole list of different types of education. Solar and metal roofing is just one topic, and there's many other topics that are covered. So I would encourage you to check that out. And it looks like we've got almost 10 minutes or so left here, so we can go ahead and look at some of the questions that came in.
Yeah, one that I see that came in the chat that I'd like to talk about briefly. I think there's a couple that we can split between us. But there was one, Andy and we kind of talked about this earlier in yesterday, but it says, I assume there are only specific metal roof products that are appropriate for the loads from the solar panels. That's kind of a loaded question. Everything is going to have a failure point, and the key to engineering design is to design for the weakest link in the chain. And so you might have what is deemed a structural standing seam, like a 3-inch trapezoidal folded profile, that is going to have better spanning characteristics than, say, a 1-inch batten cap architectural steep slope roof. When you're doing pull tests, one roof is probably going to perform much better than the other roof. The question is does that make that 1-inch batten cap no longer a PV candidate? And that question, it can only be answered by looking at what the design loads of the PV system are and how that compares to the design loads of the roof. So if the design loads of the PV system are not as great as the roof, then yeah, obviously it's still a candidate. There definitely are some that are better candidates than others. The reason I bring up the 1-inch batten cap is because that roof really doesn't have a whole lot of flexural strength. It's more of an architectural roof. Where you look at some other roofs that they are designed to have great spanning characteristics and be more of a structural component.
Type of roof is also going to impact, we were talking earlier about load distribution on the roof and the attachment of the rails. The type of roof, the capacity of the roof is also going to impact how often you're going to have to distribute that load. So that's something, again, that the designer will take into consideration. And that's the designer of the roof as well as the designer of the PV system.
Somebody asked a question related about exposed fastened versus non-exposed standing seam panels with respect to wind pressure calcs. Is there really a difference between the two? Underneath the roofs, it all depends on how far the clips are as far as tributary area, but how do you answer that?
Yeah, no, I think, I'm going to read between the lines. I think he may be actually referring to panels that are exposed to open air as opposed to covered by the module.
Oh, okay.
I think that's what that means. So I'm going to assume that, and that's the question. So what happens? Okay, yeah, there's been some confirmation there. So as I mentioned, ASCE 7 breaks this down into rack mounted, so that's not the terminology they use, but effectively rack mounted systems on low slope roof versus flush mounted systems on steeper slope roofs. Obviously you have to design the roof for the wind loads, both with and without, maybe that's not obvious, both with and without the PV system, because it's not guaranteed it'll always be there. That's number one. But yeah, when you're talking about combining wind loads for that are generated by the PV system and for the roof at the same time, all I can tell you is there's not a lot of guidance. There's no guidance on that in the code itself. So essentially that would mean that you design everything for the worst case at the same time. But if you want to dig into the commentary of ASCE 7, 2016, they talk about this in some of the testing that's behind those provisions, and they do reference some instances, particularly for flush-mounted systems, where the wind load on the roof panel was in fact reduced somewhat by the wind load acting on the panel itself. Again, the provisions of the code don't say you can take a reduction, but there is some background research in there. I would direct you to that research. So that's the key takeaway on that one.
Yeah, and I mean, correct me if I'm wrong, but also that CIOC PV paper 2 allows for some of those wind reductions. And in many cases, CIOC PV paper 2 will supersede what's written in ASCE 7. Because it takes a more specific look at solar/roof combinations. But in the gist, it's going to vary widely. But if you're utilizing a flush mount system and have an air gap in between your modules, there are some provisions that will allow for load reductions in those type of situations.
I also want to real quickly answer this question that came in. It says like PV should be treated like a dead load since it's presumed it'll be on the roof for 3+ years. So here's the key point. We actually in the metal roofing industry in particular have talk a lot about collateral loads, okay, collateral dead loads, and while not specifically mentioned in most codes, the concept's pretty well accepted, and that is that a collateral dead load is a dead load that is not necessarily there for the life of the building. And so it's treated like a dead load in the load combinations, but there's one exception, and that is that you don't use it to resist uplift. So that collateral loads, putting the weight of the PV system, and of course that would include the wiring and all the other things, rooftop equipment, that should really be called a collateral load for those reasons. A, you don't know it's going to be there the whole entire life of the building, but also B, it may not be over the whole building, and you get into an unbalanced load situation that should be investigated. And so you would discount that portion of the dead load. But that's a very good question.
Something also related to the exposed roof, the strength of the roof versus a solar that I think is very intriguing is there's a whole nother type of products called wind clamps. And those are basically, this is for standing seam metal roofs. Those are clamps that are put over the seams, and the purpose of them is to strengthen that roof from wind uplift. And by chance, the way solar is mounted on a metal roof, on a standing seam roof, is ultimately by these clamps as well. So it can be seen as, it's really not calculated or actually talked about very much, but it can be seen as strengthening that roof. And there is evidence of that. There have been some hurricanes that have hit, and there's houses that have had solar on them with standing seams with metal with clamps that have withstood the hurricane, and nearby buildings did not withstand it. And FM Global has actually documented written papers on that topic. So in some sense, with metal standing seam metal roofs, attaching the using clamps to hold the solar system also strengthens the standing seam roof itself from uplift.
Yeah, I mean, we've also seen that in the laboratory on, full scale tests that illustrate the introduction of a solar assembly with a seam clamp, improving the performance of the overall roofing system.
Did you see the question that just came in about the rack system on a flat roof?
Yeah, I'm having a look now.
So I'll make some comments on that. I mean, that's really the gist of this whole conversation, and Lillian really drove into the key question. The answer is it depends. I wouldn't rule anything out going into a solar project. I would look at all of these individual options, flush mounted, rack mounted. You can model them from a production standpoint, considering those factors, and really tune in the performance of the PV system as a whole, including the roof, and have it dialed in on what you're trying to accomplish. You've got project goals for any given project, that you want to be sure and address those. So I would tell you that you don't discount anything, put everything, consider all your design options, but certainly flush mounted on a roof in steep slope roofs, and both low slope and steep slope roofs can give you a very competitive answer there. So we'll definitely look at that.
Yeah, and I mean, kind of to hit both of these high wind loads, I see there's also one in the Q&A part about minimizing the effect of wind load, and there definitely are ways to do that. We touched on them before. Flush mount systems providing an air gap around all four sides of the module are really good ways to minimize the effect of wind loads, and so that, yeah, it's less of a severe case. I mean,
generally, the lower the profile, the better from a wind perspective. I know tilted systems, some of them have wind screens in front that create an aerodynamic effect that reduce the uplift, but generally, the lower your system is to the roof, the better it is from a wind perspective.
All right, well, we've reached a little past the hour now. I think we've covered most questions here.
I think I'll mention one other thing. I'm scrolling through regarding the galvanic action. I think Daniel made a comment that the clamps sometimes dig into the ribs. So if you did, then it's a very, very good point, and should be looked at. If you look at the individual pieces of hardware for this, some of them, the set screws that connect to the rail actually have rounded tips for that very reason, to do everything to protect the coating, because that's obviously very important. The paint is not just the coating. Remember, there's a metallic coating underneath the paint as well, and you want to protect them both. But yeah, that's a very good point. And I will just say, just look closely at the attachment method and the type of fastener or set screw that's there, and make sure that it's curved button.
A question from Everett that came in from New Zealand. That one's kind of special to my heart because it's the territory space that I do a lot of work in. We can definitely talk more about lifting up flush mount systems for cleaning under the modules. New Zealand is notorious for growing things on roofs. Even metal roofs, they have a lot of things that grow on them. So the getting underneath the modules to actually clean the roof so that it doesn't create moss and mold and other funny things that happen to grow in New Zealand. And there has been some things that we've done to work on that. I don't know a good way for you to get a hold of me other than just go to our website and click on support and ask for Dustin. And you can reach me directly, and I'd love to chat with you about it.
Great. Well, I appreciate everybody's questions and participation today. I want to thank the panelists. And I believe all of us will probably be at MetalCon this October in Indianapolis. So if you'd like to chat in person, put it on your calendar for MetalCon in Indy. Thanks for your time.
Absolutely. Thank you, everybody. As a friendly reminder, you will be getting that very quick and brief survey that's going to come through at the end, just so we know where to send those certificates to you. If you have any additional questions, you can always reach out to info@metalcon.com, and we will share that information with the appropriate parties. If you have any other pertinent issues, again, you can reach out. If you know any of us directly, reach out to us, or you can reach out to MetalCon and we'll get that information to whoever needs it. Thanks everyone for being here with us today, and a very special thanks to all of our panelists and Andy Williams, Dustin Haddock, Leanne Slattery, Bob Zabzik, and of course, Mark Geis. Thanks everyone, and have a great rest of your day. We will be excited to hear from you in the near future, and we hope you join us on March 6th. Bye everybody.
Thanks, everybody.
Thanks.